Okay, so welcome back to part 2 of the video. And in part 1, we learned about solving systems of equations using substitution. In part 2, we're going to learn about solving systems of equations using elimination. So the first thing we need to know is, what does it mean to eliminate something? Well, if you eliminate something, you get rid of it. So when we say we're going to eliminate a variable, what that means is we're going to make the variable cancel out. So make the variable cancel out. So let's just try a couple of examples of canceling out or eliminating something. So if I wanted to eliminate this positive 3, the way I eliminate it is to make the positive 3 cancel out by doing the exact opposite. So the opposite of plus 3 is minus 3, and it cancels out. To eliminate y, I'm going to do minus y. And I'd like you to pause the video right now and go ahead and do 4, 5, 7, and 8. And then start it back up and make sure that you've got the correct answer. Okay, so just quickly scan and make sure you got the correct answer for elimination. And then, so really when you're combining like terms and you want to eliminate, they need to be opposite like terms. One needs to be positive and one needs to be negative. So our steps for solving systems using elimination, there's 4 steps. First, we line up our like terms. Easiest way to do this is if your equations are in standard form. And step 2, we're not going to cover today. We'll cover this next class, which is multiply if necessary. So we're not going to do that today. None of them will be necessary. So then we're going to add the equations together and solve them, and then we'll substitute in. So just stick with me and see how this goes. So what we've got here on number 10 is I'm looking for something I can eliminate. So I've lined up my terms. So my x's are on top of each other, my y's, and my numbers. And I've got opposite like terms. I've got a plus x and a minus x. So if I add this equation, the top equation to the bottom equation, if I just add them, my x's are going to eliminate. So x minus x, that just crosses out, so I'm not even going to bring it down. 3y plus 2y is 5y, and 17 plus 18 is 25. Let's do that right, 25. Okay, so we've got 5y equals 25. We divide both sides by 5, and we come up with, let's just write it here. 5y equals 25. We divide both sides by 5, and we get y equals 5. Now that we know y equals 5, we can plug that back into one of the equations. Doesn't matter which one. I'm going to go ahead and do the top equation to get what my x value is. So I've got x plus 3, and instead of y, I'm going to substitute in my 5, equals 17. So x plus 15 equals 17. I subtract 15 on both sides, and I've got x equals 2. So my solution is y equals 5, x equals 2, so my ordered pair is 2, 5. So that's how we do elimination. So let's go and look at number 11. Okay, so on number 11, if I'm going to be using elimination, I am looking for opposite like terms. So I've got a positive 2x and a negative 2x right here. So when I add those together, they're going to eliminate. They're going to cancel out. So let's go ahead and just eliminate these, add this together. So these cross or cancel out. 3y plus negative y is 2y. I'm going to bring it down here. Equals 10 plus negative 2 is 8. So when I divide everybody by 2, y equals 4. So now I'm going to pause and I'm going to go ahead and substitute in the 4 for the y value in one of my equations. I'm going to go ahead and just do the top equation. So I'm going to say 2x plus 3, but instead of y, I'm going to substitute in 4 equals 10. And then I'm going to bring it down. So I got 2x plus 12 equals 10. Subtract 12 on both sides. And I've got 2x equals negative 2 and x equals negative 1. So my solution is negative 1, comma 4. Okay, on number 12. This time it's not an x that we're going to be eliminating because I can look right here and I've got opposites. I got positive y and negative y. So when I add this together, my y's are going to eliminate. So I want you to do this one on your own. So work all the way through the entire problem, coming all the way down to having your ordered pair. Pause your video while you do the work, and then start the video back up for the explanation. Okay, go ahead and check your answer. Make sure that you did all your math correct. All right, so in summary, what we learned today was solving systems of equations using either substitution or using elimination. And sometimes it's easier to use substitution, other times elimination is better. So what we're looking for in substitution is when we have an isolated variable. So when we have something y equals or x equals already ready to go. And when I say an isolated variable, even better is a coefficient of 1. Meaning there's not even anything to divide. You either have x equals 3x plus or 3y plus 4 or y equals 2x plus 5, something where the x or the y are all by themselves. That's best for substitution. For elimination, we want to look for lined up opposite like terms. So when you find ones that you can just line them up and go, hey, I can eliminate, that's the best process. If you have one that's got an x equals something, substitution will be the best process. If they're both already in slope-intercept form, then graphing will be the best process. Tomorrow we will start working on you deciding which process is best based on the system.